In this video we will look at flexible pavements in a little bit more detail. Almost all roads in New Zealand have a flexible pavement. This is because they are less expensive, more resilient to land movements, and easier to dig up to access underlying services and less noisy. A flexible pavement consists of a subbase and base course aggregate layers topped with a chip seal or asphaltic concrete surfacing. The requirements for the materials used in both the aggregate and the surfacing are set out in specifications, which are a series of documents that set out what properties we need to test, how we need to test them, and what results are considered acceptable. We will look at the NZTA, the New Zealand Transport Agency, specifications in the next few videos, but other organisations such as local councils may have their own specifications to suit local conditions and the materials they have available. Note that NZTA specifications may start with either NZTA or TNZ. The TNZ notation stands for Transit New Zealand, which is what the NZTA was called when those particular specifications were prepared. The subbase needs to distribute the loadings from the base course down to a level that can be resisted by the subgrade. Another function is to minimise the intrusion of fines from the subgrade into the base course. Fine soil materials such as clays and silts can migrate upwards where they prevent water draining out of the base course and lessen friction between the aggregate particles. The subbase also improves the drainage of water out of the base course and prevents water ponding in the base course layer, which will also decrease the strength of the base course layer. Subbase is generally less effective at distributing loads than base course and may be made out of less strong rock. However, it does not need to be as strong as base course, as the base course distributes the loadings so that the loadings at the subbase level are lower than on the base course surface. We use subbase because it is less expensive than base course, but it is still able to transfer and distribute the road loadings to the subgrade. NZTA only produces a set of notes providing guidance on what the material should do. These notes are called the M3 notes. This is because the types of aggregates that may be used as subbase varies across New Zealand. The more specific details are usually contained in the local council codes of practice. The other relevant specification is B2, specification for the construction of unbound pavement layers, which provides guidance of the requirements for constructing both subbase and base course layers, and we will look at this later on in another video. The base course has to be able to resist all traffic loadings, including the vertical loadings from the weight of the vehicles and the horizontal loadings from vehicles accelerating, braking and turning, and also distribute the loads to the lower levels. Therefore, it needs to be the strongest layer of the pavement. The strength of an aggregate layer is attained from the contact between the aggregate particles, both in distributing the load down through the layer but also in supporting the individual aggregate particles. An aggregate layer is strong when there are multiple contact points between the aggregate particles and when the particles are tightly locked together. The base course material is designed to do this most effectively. This is achieved by having the right mix of aggregate sizes so the coarser materials are in contact with each other and are held in place by the smaller particles in the spaces between the coarser particles, which are in turn held in place by even smaller particles. The smaller particles may also help distribute the loads through the aggregate layer. The NZTA specification for base course is TNZ M4, specification for base course aggregate. It provides a detailed description of the required properties of the base course, including the testing to check those properties and the acceptable results. The other relevant specification is TNZ-B2, specification for construction of unbound pavement layers, which provides guidance for the construction of subbase and base course layers. We will be looking at both these specifications in the next topic. The surfacing or wearing course is usually designed to provide a waterproof surface and a running surface for the traffic. It usually does not carry the vertical loads from the traffic It has to be able to resist being torn apart by the lateral forces, the horizontal forces caused by turning, braking and acceleration of vehicles, but the loads themselves are resisted by the base course. The adhesion between the surfacing and the base course has to be able to resist these lateral forces, otherwise the surfacing would ride up like a carpet on a wooden floor. There are a variety of different types of surfacing, which is reflected by the number of specifications. M1, M2 and M10 provide guidance on the materials used for various seals, while P3 and P4 set out the processes for different sealing operations. There are other NZTA specifications, but these are the ones we will look at on this course. We will discuss surfacing specification in a later video.